Since 200 BC, steel has been produced in cultures around the world in one form or another. Steel has been a part of some of mankind's greatest achievements in history. Steel was the iron horse that connected the two coasts of a budding nation. It's the backbone of modern skyscrapers, the framework for cars, and it continues to affect our everyday lives. Steel is everywhere, from kitchen appliances, utensils, toys, and the toe caps in protective footwear, to precise surgical instruments used in hospitals, durable frames in housing, and even in high-tech equipment in space shuttles. Steel is an alloy of iron and carbon, containing less than 2% carbon, 1% manganese, and small amounts of silicon, phosphorus, sulfur, and aluminum. Steel is one of the most important engineering and construction materials in the world. Every year, over 1 billion metric tons of steel are produced worldwide. In 2004, China ranked as the world's largest producer of steel, with more than 272 million tons of crude steel. Japan followed with 112 million tons of produced steel, with the United States coming in third at nearly 99 million tons of steel. In that same year, China was the world's largest user of steel, using 265 million metric tons of finished steel. The United States ranked second, utilizing 116 million metric tons, with Japan following third with 77 million metric tons of steel used. It's important to note that steel is not one single product. There are currently more than 3,500 different grades of steel, with a large variety of physical, chemical, and environmental properties. And of that number, about 75% have been developed just in the last 2 decades. Modern steel has advanced so much since the early days of steel that if the Eiffel Tower were to be rebuilt today, the engineers would only need 1/3 of the amount of steel originally used. Modern cars are built with new steels that are stronger, but up to 25% lighter than in the past. Steel is also 100% recyclable. It can be recycled indefinitely without ever losing strength or durability. Today's steel is made through one of 2 basic methods. The first is the integrated steel mill method, using a blast furnace combined with a basic oxygen furnace. The second way is the mini mill method, using an electric arc furnace, or EAF. The integrated steel mill's blast furnace combines raw iron ore, coal, converted into a pure carbon form known as coke, and limestone to create iron. The iron ore is reduced to molten iron using coke, heating oil and oxygen as the sources of energy, and limestone to remove impurities from the melt. The molten iron from the blast furnace is further refined into steel in the integrated steel mill's basic oxygen furnace, or BOF, by combining approximately 70% molten iron and 30% scrap steel, and by using oxygen as the fuel for heating. Small additions of metallic alloys are then added to the molten steel to produce the chemistries required for various end-use applications. The mini-mill electric arc furnace method uses a charge of 100% scrap or scrap substitute, which is then melted using an electric charge to produce recycled molten steel. The molten steel is further adjusted by fine-tuning the chemistry and temperature before casting into a solid slab of steel. Each slab is then reheated to approximately 2,300 degrees Fahrenheit to ensure a uniform temperature prior to being rolled into sheet. Each steel slab is then passed through the roughing stand several times before being rolled to its exact specified size in the finishing mills. Slabs can be rolled into flat steel sheet or plate. Flat steel includes either plate products or sheet products. Plate products are thicker than sheet and are used for shipbuilding, construction, large diameter welded pipes, and boiler applications. Sheet products are thinner and used in automotive body panels, household appliances, steel or tin cans, and a number of other products from office furniture to heart pacemakers. Long steel products include rods, bars, and sections. Typical uses include reinforcing rods used in concrete, engineering products, gears, tools, seamless pipes, and building projects. During the steel making process, a number of byproducts such as slag, light oils, ammonia, iron oxides, and coal tars are captured and sold. These byproducts are used in road pavement, cements, fertilizers, plastics, electronics, and roofing compounds. So, after all of this, why does steel rust? When exposed steel comes into contact with water and oxygen, there is a chemical reaction, and the steel begins to change to its original form of iron oxide. In most modern steel applications, this problem is easily overcome by coating, using a variety of different materials to suit your needs. From the sidings on buildings to the car you drive, steel is used in nearly every corner of your life. It is one of the most important engineering and construction elements in the world. Brought to you by the National Coil Coating Association.